So we would measure how far they flew down the hallway and keep track of which different like wing folds and stuff was the best flight. And we also had to figure out, so basically at the end we took all our data from practicing flying them back to the computer, plugged it all in, found the average distance for each of the different combinations. We had 9 combinations of these different parameters. And then we found the standard deviation from that, that average. And the point was, we were hoping to find the airplane that both flew farthest and varied the least.
While people are throwing airplanes, are you writing this down?
We went out in a hallway and I had a paper that had this part of the table.
Yeah.
And literally, Tony would throw the thing and I would write down, and no, Tony wasn't the thrower. John would throw it. Tony was standing out there. He would look, he would estimate kind of how many feet it was based on the tiles. Because our teacher said the tiles were a foot. So he put a quarter at 5 tiles, he put another quarter at 10 tiles. He had this little bookmark he put at 15 tiles. And so he would guesstimate how many tiles it went to. And then he would call it and I would write it down, he would throw the plane back to John. And we did that 9 times per plane. Straightforward. There was an example chart in the book that we hand wrote all the numbers into, and then we so we could tell that even though some of the ones who had a really high average distance, they also had a high standard deviation. And if you take the standard deviation and stick it up here, you'll find that it could be as high as 25, but it could also be as low as 15, which means that the likelihood of the plane always flying 20 feet is not so much.